Okay, welcome back. And so today we're going to cover more of quadratic functions, and this time we're going to talk about graphing quadratic functions. And so again, we've graphed them before, but now we're going to introduce a new form that will help us graph these. Okay, so to start with, let's start with the form. So this is using almost like using transformations, if you want to think of it that way. So here's what we have. So using graphing techniques, right? So notice that all quadratic functions can be put into this form. Okay? So we have this a value out here. We're multiplying by some a value. We've got x minus h on the inside squared plus k. So it looks much like a transformation of sorts, right? So we've got something going on the outside. So this is a vertical stretch or compression. We've got an h in here. So again, this is going to be a a horizontal shift. And then this is outside, which means we're going to have a vertical shift. Okay? So a couple of things to keep in mind. So notice that this is subtraction and this is plus. So this is always the form that we use. And so I'm going to explain to you why we want this to be subtraction and why we want this to be plus. Okay? But let's talk about the a value. So again, a is outside, so a is some real number. Okay? Or a complex number. So if a is positive, right? So again, we're assuming a is positive. If a is bigger than 1, it's a what? Vertical stretch. If a is between 0 and 1, then it's a vertical shrinking. Okay? Now, if we have a subtraction here, then what happens is if h is positive, then it's a horizontal shift to the right h units. If h is negative, it's a horizontal shift to the left h units. Okay? So again, just keep that in mind. If this is negative, then, excuse me, if this is a subtraction, then if h is positive, we're going to the right. If h is negative, we're going to the left, which is what we would think, right? But again, we have to have the subtraction sign to make it work that way. Okay? Now, the plus sign, same thing. This is a vertical shift. So if k is positive, we're moving up. If k is negative, we're going down. Okay? And so that's the way to understand that. So now let's use this, and we're going to graph some of these. And so what I'm going to do is I'm going to do the first one just by plotting points. Okay, so we're just going to plot points. So the old-fashioned way, right? So we're just going to plot points for A. Okay, and so if x is negative 1, we get what? X is negative 1. Negative 1 squared is 1. Minus 4 times negative 1 is negative 4, right? But we're doing minus a negative 4. Minus 2. And so what do we get? We get 1 plus 4, which is 5, minus 2 is 3. So we get 3 here. Okay? Well, what if we put 0 in? Oh, this would be easy, right? If we put 0 in for x, we just get negative 2. If we put 1 in for x, well, 1 squared is 1, minus 4 times 1 is 4, minus 2. And so in this case here, we get 1 minus 4, which is minus 3, and then minus 3 and minus 2 is a negative 5. And so let's do 2. So 2 squared, right? 2 squared is 4, minus 2 times 4 is 8, minus 2. And so we get 4 minus, what does this become? This is minus 10. So 4 minus 10 is what? Make sure I did that right. So 4 minus 8, good, minus 2. Yeah, so we get what? Minus 6. And then 3. 3 squared is 9, minus 4 times, minus 4 times 3, which is 12, minus 2. And so we get 9 minus what? Minus 14. So 9 minus 14 is a negative 5. And then let's do 4. One last one, 4. So 4 squared is 16, minus 4 times 4, which is 16, minus 2. Well, the 16 minus 16 is 0, so that gives us a negative 2. Okay, so notice what's happening here. So what's happening here looks like we're getting negative 5, negative 2, negative 2. Okay? And so it looks like we're starting here at 2, negative 6. Oops, I didn't go far enough. Okay, so we're at 2, negative 6, so it looks like we're down here, right? And then we're going to 3, negative 5. So we're going up to, let me plot this a little better. Okay, and then we're going to go to 4, negative 2. So 4, negative 2, and then we're also at 0, negative 2, which is right here. And so our parabola looks like it does something like this. Oops. Okay, so there's our graph. Okay, so I didn't plot all the points, but again, five points is plenty for a parabola. And so it gives us the sketch of the graph. Okay, now, looking at this graph, what is the domain? Well, the domain, look at all the values of x. Well, the domain is all real numbers, right? Because it goes off to infinity that way, and it goes off to negative infinity in the other direction, in the negative direction. And so this is the domain is all real numbers, and the range, now where's the range? The range are all the y values. Well, the y values start where? At negative 6. So there's no y values less than negative 6. So the range is negative 6 to positive infinity. Okay, so if we were going to do the domain, so domain is negative infinity to positive infinity. The range is going to be negative 6 to positive infinity. Okay? And again, if you want to, since this is all real numbers, if you want to use the bold-faced R, that would be fine too. Okay, so now what about B? B, now we're not going to use a table, so this is more of the old-fashioned way, right? We plot points, we sketch it, and we look at the graph. Okay? Now let's use this and let's compare it to the basic squaring function, x squared. Well, what are we doing? Well, let's start with the basic function. And this time I'm not going to use transformations directly. So just think about what the basic function looks like. It's a parabola that's centered at the origin and opens upward. And we know that it goes through 1, 1, 0, 0, and what? Negative 1, 1. Okay? So we know it goes through those 3 points. So let's use that to our advantage. So now what is this g function, g of x, doing? It's taking the negative 1/2 of f of x. So in other words, we can write this as negative 1/2 of f of x, where f of x is our basic function. So we're taking negative half of our basic function. So what's going on? Well, first there's a reflection, and then we're taking 1/2 of all the y values. So what's happening here? Well, the origin doesn't move, right? That's not going to change, right? If you reflect across the x-axis, you're still going to be on the origin. If you take half of the origin, 0, you still get 0. And so the origin's not going to move. But what happens to this point here? 1, 1. And negative 1, 1. What happens to those 2 points? Well, we're taking 1/2 of the y values. So this y value 1 and this y value at 1 is going to become 1/2. Okay? And not only is it going to become 1/2, but it's going to be the opposite. So it's going to become negative 1/2. Right? So if we compare this to the basic function, then this point is going to move down to here. Right? So it's going to be cut in half, so it's going to go down to 1/2, but then it's going to be flipped down to negative 1/2. So it's going to be down at negative 1/2, and this is going to be down at negative 1/2, right? And so at 2, right, when x is 2, if we're talking about the basic function, 2 squared is 4, so we're going to be down here, right? We're going to be up here. But what are we doing? We're taking 1/2 and then reflecting it. So 1/2 of 4 is 2. And then the opposite of 2 is negative 2. So that's going to bring it down here to negative 2. And then likewise over here, we're going to have negative 2, 4. Half of 4 is 2. And then we're going to reflect it down to negative 2, which means this is going to be at negative 2, 2. And so we end up with a parabola that looks like that. Okay? Now, again, I could draw the transformations, and I encourage you to draw out the separate functions and do the 2 transformations separately. I encourage you to do that if that's going to help you get the correct answer. So the first thing I would do, and again, it doesn't matter which order you do this in. You could take the basic function, x squared. You could apply the reflection first, so you reflect everything down, and then take half of the values. So you could end up doing it that way. Okay? Now, what about C? Let's look at C. C is now, what we're doing is we're taking this function, right? We're taking this function because it's still the negative 1/2. So basically what we're doing is we're taking this function and we're applying 2 transformations, a vertical and a horizontal shift. Okay? So now, notice that it's subtraction here. We're subtracting off an h, or excuse me, yeah, h is positive. So that means we're going to be moving to the right. Okay? But also, remember what I said in an earlier video. If I subtract off a number of units, it's the opposite of what you would think. So subtracting off units would mean I'm going to the right. Okay? Okay, so now what I'm going to do is I'm taking this graph and I'm moving it 4 units to the right. So this point is going to move to 4, right? So let me put this here. The origin is going to move to 4. This point is moving to 5, so that's going to be at negative 1, 5. This point is moving to 6, so it's going to be 6 comma negative 2. Okay. And then this point here is moving from negative 1 to 3. So we're going to move from negative 1 to 3. So it's going to go to here. And then this one here is going from negative 2 to positive 2. So we're going to go from negative 2 to positive 2. So it's going to be about right there. And so we get something that looks like that. Okay? So that takes care of this inside. Now what is it doing? Now we're going to add 3 outside the function. So this is a vertical shift upward, right? So again, plus, and this is positive, so it's moving up. Okay? So now we're going to move this value up. So this is going to move up to 3. So this is going to move up to, oops, sorry, this should be 3. This is going to move up to 3. And so all the rest of the points are going to move up 3. So this is going to move up to 2. This one's going to move up to 2. And this is going to move up to 1. And this is going to move up to 1. Like so. And so this is the resulting function. Again, I could use different colors and I could use the transformations, and I kind of ran out of room here to do a good job. But again, just make sure that when you're doing these, that you show me the transformation. So especially with this form, okay, because this is a form that uses transformations, okay? So again, this is just showing you how we could do it with a table, but what I'm more interested in is how we do using transformations, using this, especially when we come to this right here. Okay, so again, you start with the basic function, you apply the reflection, the half, then you do your transformation or your translations. Okay, and so that's it. So again, practice these, do other examples, and if you have questions, let me know and I'll do some more.